Hello class, welcome to lesson 10.4, which is all about radical equations. By the end of this lesson, you should be able to solve those radical equations as well as solve radical equations with extraneous solutions. Okay, so extraneous solutions are, let's see if my pen will work this time, there we go. Extraneous solutions are something that we'll talk about in our last example, and we'll go through what exactly that means, okay? But before that, let's practice solving equations. So just some reminders that if we have two numbers and we know, let's say we have a variable a, and we know it's equal to b, that would be a situation like 1 equals 1, right? So if I said a squared equals b squared, that would mean 1 squared equals 1 squared. I think we would all agree that that is true, okay? But if we were to look at something that looked like this, where we have the square root of x equals 4, remember we've talked a little bit about how to undo a square root. You take the square of both sides, so then we have x equals 16. And if you were to plug that number in to your original, the square root of 16 gets you back to 4, which is what we started with. So we know that that solution works. Alright, so let's talk about example 1, where I give you an equation with a variable, and that variable is going to be underneath your square root. Alright, so the equation v equals the square root of 2.5r represents the maximum velocity that a car can travel safely on an unbanked curve when v is the maximum velocity in miles per hour and r is the radius of the turn in feet. If a road is designed for a maximum speed of 65 miles per hour, what is the radius of the turn? So we're given 65 for our velocity, so I'm going to plug that in. 65 equals the square root of 2.5r, and we're trying to figure out what r is, what the radius is. So just like we did on the last one, I'm going to take that equation, and I want to get rid of that square root, so I'm going to square everything there. That means I'm going to square everything on the left-hand side. So 65 squared gives me 4,225, and that ends up equaling 2.5r, because that square root the square gets rid of that square root. Then if I tee it up, I'm going to divide both sides by 2.5, and I'm going to get 1,690 is the radius. So 1,690 turn in feet, so I'm going to say feet. That is the radius of the turn. Alright, why don't you go ahead and try to solve this one on your own. Good luck. Hopefully you ended up with 784 feet. If you have any questions about that, please be sure to reach out for some help. Let's look at our example 2, where we want to solve each equation. So the first thing you're going to do when it comes to solving these equations is you want to get it so you have everything in the square root on one side. So kind of like we used to try to get the variable by itself. Now before we can do that, we have to get the square root by itself. So I'm going to start by moving this minus 2. So undo that minus 2 with a plus 2. And what I do to one side, I must do to the other. So now I have a square root of c minus 3 equals 6. If I want to undo that square root, I need to square both sides. So I'm left with c minus 3 equals 36. Then I take that c minus 3, I add 3 to both sides, and c is now by itself, and I have c equals 39. Okay? Let's try another one, because practice always helps. So I'm going to tee it up, and the first thing I'm going to move is the 4. I'm going to subtract 4 from both sides, so that way I'm left with everything in the square root on one side. 14 minus 4 gives me 10. Again, undo the square root with the squared. I'm left with h plus 1, so everything inside my square root equals 100. if I subtract 1 from both sides to get h by itself, I have h equals 99. And that would be my solution. Why don't you go ahead and try solving this one on your own? Good luck. Hopefully you got 60 as an answer. If not, please be sure to reach out for some help. All right, now our last example for today is going to be example 3, where we want to solve each equation, but this time I'm going to make you check your solution. Okay, that's going to be the very important part where we talk about extraneous solutions, like I mentioned at the beginning of the video. So extraneous solutions are going to occur when you have the variable on both sides, and I'll show you what you some clues to look for that. So I have square root of t plus 5 equals t plus 3. So the first thing I want to do is get rid of this square root. So I'm going to square both sides. So since I'm squaring everything on the left-hand side, I have to square everything on the right. So I'm left with t plus 5 equals, and then remember t plus 3 squared is the same as saying t plus 3 times t plus 3. So I'm going to have to FOIL, and I get t squared. So I'm going to write that up there. And then plus 3t plus 3t plus 9. So I have a total of 6t. So t squared plus 6t plus 9 is what I have on the left-hand side. Now, I want to find out what numbers make this true. So the next thing I'm going to do is I'm going to move everything to one side and have it equal to 0, like I did in the last 2 chapters. So what I'm going to do, I'm going to move that 5, and I'm going to have t equals t squared plus 6t plus 4. Then I'm going to move the last t that I have. So I have 0 equals t squared plus 5t plus 4. And if you want to move the 5 and the t at the same time, that is totally fine with me, okay? Go ahead and do that. I now have 0 equals t squared plus 5t plus 4. I want to see how can I factor this. So if I have 0, I want to know what can I write in there. So if I make my x, remember the middle number goes on the bottom, and you want it to add to that number. And then you're looking for numbers that multiply to your last one. So we're looking for 2 numbers that multiply to 4 and add to 5. So I know 4 and 1 are going to be my answers. So I'm going to put a 4, 1, they're both positive. And then my variable is t. Okay. From here, remember, you take each of your numbers, so everything inside one parenthesis, so t plus 4 equals 0. And you take your t plus 1 equals 0, and you solve. So I say minus 4 minus 4. I have t equals negative 4. Or minus 1 minus 1, I have t equals negative 1. Alright, so I have 2 solutions here. But the last thing I need to do is I need to plug those numbers in. So I want to look, if I plug a negative 4 and a negative 1 in, what happens? So if I do the square root of negative 4 plus 5, and I say that equals negative 4 plus 3, so I plugged it into my original equation before I squared anything. I have the square root of 1 equals negative 1. The square root of 1 is 1. Is that true? No, 1 does not equal negative 1. So that means t equals negative 4 is extraneous. It is an extraneous solution. So extraneous solution is when you plug that number back in and it doesn't end up working. That becomes an extraneous solution. So let's see what happens when we plug a negative 1 in. So if I do the square root of negative 1, negative 1 plus 5 equals negative 1 plus 3. Negative 1 plus 5 gives me the square root of 4 equals 2, and the square root of 4 is 2, and I have 2. That's true. So t equals negative 1 is a real solution. I will ask you to identify extraneous solutions on your homework, so you need to make sure, and for sure on the test, you need to make sure that you know how to do this process, okay? I know it might seem like an unimportant step, but it is very important that you guys know how to do this, okay? So I'm going to move that just over to the other side so that way we have some space to try our next problem, okay? Now, if we scroll back up and try our second problem, I'm going to get rid of the arrow. We have x minus 3 equals the square root of x minus 1. So I do the same thing. I square both sides. X minus 3 squared is the same thing as x minus 3 times x minus 3. That's x squared minus 3x minus 3x plus 9, or x squared minus 6x plus 9. So x squared minus 6x plus 9 equals x minus 1. Then, if I move my 1, I have x squared minus 6x plus 10 equals x. Then, if I say minus x, I have x squared minus 7x plus 10 equals 0. Then I'm looking once again for numbers. I'm looking for two numbers that add up to a negative 7 and multiply to 10. If I think about that, numbers that multiply to 10 are 10 and 1. Those won't add to negative 7. Or I could do negative 5 times a negative 2. Those multiply to a positive 10, add to a negative 7. So I'm going to say negative 5, negative 2. And if I keep going from there, I would say x minus 5 equals 0, or x equals 5. X minus 2 equals 0, or x equals 2. Now I need to see, are these answers real or extraneous? So I have x minus 3 equals the square root of x minus 1. So we have x minus 3 equals the square root of x minus 1. So if I plug those numbers in, if I plug 5 in, I have 5 minus 3 equals the square root of 5 minus 1. 5 minus 3 gives me 2. Square root of 5 minus 1 is 4. So I have 2 equals 2. So I know x equals 5 is a real solution. If I plug a 2 in, I have 2 minus 3 equals square root of 2 minus 1. So I have a negative 1 equals the square root of 1, or negative 1 equals 1. So that means x equals 2 is an extraneous solution. Alright, why don't you go ahead and solve y equals the square root of 2y plus 3. You only need to list real solutions, I believe. Good luck. Hopefully you got letter A. If you have any questions at all, please be sure to reach out for some help. I'm more than willing to assist you. Have a great day.